To write the balanced net ionic equation for NaOH plus H2SO4, that's sodium hydroxide plus sulfurous acid, we'll use these rules here. The first thing we need to do is balance the molecular equation here. We can see we have two sodiums here and just one here, so I think we'll have to put a 2 in front of the sodium hydroxide. Then if we put a 2 in front of the water, that balances the molecular equation. So we have our balanced molecular equation. Now we write the states for each substance. So sodium hydroxide is a strong base. It's going to dissolve and dissociate. The sulfurous acid, it will dissolve, but it is a weak acid. We have sodium compounds, very soluble, and water, that'll be a liquid. So we have the states. Now we can split the strong electrolytes apart into their ions. This table here is something you might want to memorize. It's a list of the common strong acids and strong bases. We're looking for sodium hydroxide, which is right here. Sodium hydroxide is a strong base. That means it's going to split apart into its ions. So sodium, that's in group 1 on the periodic table. It has a 1 plus charge. The whole hydroxide is 1 minus. For the sulfurous acid, we don't see that. We see sulfuric acid, but not sulfurous acid on our list of common strong acids. So this is going to be a weak acid. It's not going to dissociate, so we're not going to split it apart. So we have 2 sodium ions, and I won't write the states right now. Let's write those at the end. Plus 2 hydroxide ions. And then for the sulfurous acid, that's a weak acid. It's a weak electrolyte. We're not going to split it apart. We're going to keep it together in our net ionic equation. And those are the reactants. The products, sodium group 1, 1 plus charge, and then this whole sulfite ion, 2 minus. So we'll have 2 sodium ions, just like the reactants. And then we'll have the sulfite ion, SO3, 2 minus. And then with net ionic equations, we don't split water apart. So we'll have our 2H2O. This is the complete ionic equation. Now we can cross out spectator ions. They're on both sides of the complete ionic equation. So we have our reactants and our products. And the only thing I see that is the same, 2 sodium ions here and then in the products. Cross that out. And everything that's left is unique. That makes it the net ionic equation for NaOH plus H2SO3. I'll clean this up and write the states. We'll have our net ionic equation. And this is the balanced net ionic equation for sodium hydroxide plus sulfurous acid. If you look at the reactants and products, you'll see that the charge is conserved. We have 2 negative charges, 2 negative charges here. And that if you count the atoms up, each type of atom, they'll be the same number. So mass is conserved as well. This is Dr. B, and thanks for watching.